Hi, this is Brunja. Welcome to my webinar about JavaScript. And today we're going to continue with control structures. And today we're going to talk about loops. Similarly as condition statements, we talked about last time. Talked about case and switch and if. They are similar. You can use both of them depending on your preferences, depending on the circumstance. Loops are similar. There are actually three loops: while statement, do while statement, and that's, by the way, that's my dog you're hearing scratching. And so there is a while, do while, and for loop. You can mix them and match them as you see fit, whatever is closest to what you need. Certain loops are better for, or different loops are better for different circumstances, but you can mix them and match them. So what are loops? Let's imagine you want to do things in repeat. You want to do the same thing multiple times. For example, let's say I want to write first 20 numbers. I'm already bored. It's already way too boring. Let alone if I want to repeat more than one statement multiple times. If I want to do more things than just one statement every time, I want to do multiple statements, then it would be forever. So how can we do it? Well, we create a loop, which means we create a piece of code that goes again and again and again and again. So let's start with one. Let's start with while loop. Okay, 20 numbers. So how does this work? So we have our variable start, it's a number. There's again some sort of block. And it says while start is less than 21. Again, this has to evaluate to some boolean with truthy, falsy value, something like this. This would be truthy value all the time. I'm going to talk about this. Let's write it down. Let's assign. So this is 1 plus 1 is 2. Start becomes 2, and it goes back. While is start, which is 2, smaller than 21. Yes. So let's write it into console. I can write this as well, it's the same. And 2 plus 1 is 3, start is now 3. You can do this, it doesn't matter. You can reassign the same value using the same value, because as I've said, this evaluates from right to left. So this evaluates first. So this evaluates independently, that it goes here. So when it's 19, 19 is smaller or equal than 20. Let's write 19. This becomes 20. 20 is smaller than equal to 20. Let's write 20. This becomes 21. And this evaluates to false. So we have a start, then the loops goes over and over again while this is true, and then it continues. Okay, and this we can do a few more things here. I want to show you. When you have a plus here, you can do this. When you use the same value, when you say start now becomes start plus 1, you can do this. It's actually an operator. Here it is. It's actually assignment operator, and it assigns some sort of increment. We can do 3 here. We would get plus 3. It stops here because 19 plus 3 is 22. This evaluates the false. Let's do it this way. Okay. So you can do this. You can as well do this means the same. Multiply itself by 5. Add to itself 1. When you're adding or subtracting 1, this time I'm checking out if it's bigger or equal than 1, and I'm subtracting 1. You can use even different way to write this when it's 1. Only when you're dealing with 1. You're adding or subtracting 1. You can do, what is it? Here, this. Prefix increment or suffix increment, postfix increment. Is it here as a postfix? You can do this. Okay, now okay, I need it, of course, decrement actually. Now it's running forever. In case you can put it in front or behind. It's actually different. In this case, it returns the value which is, for example, 10, and then it does the operation, in this case decrement. By the way, you can't do this. This means nothing. This can be only plus or minus. So it's 1, it returns the 1 to this function, and then it increments them. If I would do it this way, it first increments it and then returns it. So let's start with this. Let's go up to 3. So okay, it's 1. Is 1 smaller than equal than 3? Yes. So let's return 1 from this, which is gonna be 1, and increments it. It becomes 2. Is 2 smaller or equal than 3? Yes. So let's return 2 from this and increments it. It becomes 3. But let's print out it's 2. It becomes 3. Is 3 smaller than equal than 3? Yes, it is. So let's return the 3 and increments it. It becomes 4. So 3 is printed out. The start is 4. Well, 4 isn't smaller or equal than 3. So this loop ends and it continues here with done. As I've said, this is pretty much equal to this is equal. This goes from 1 to 3. This goes from 2 to 4 because it first increments it, then returns the incremented value. So this is a while loop. So it does whatever it's in block while this condition is true. Again, if you have a one single line, you can write it this way. If you have multiple lines, you have to enclose them in block. Again, I suggest you use the block all the time. If this is true all the time, what happens? Well, the cycle will gonna run forever. It will not stop. It will never ever stop. It's trying to work. It's becoming harder and harder for the computer to print out the numbers, but it's running forever. As you can see. And as you can see here, it's loading, it's running forever. Just terminate the page, please. Maybe I should terminate the whole Chrome. Nope, this is enough. Let's kill it. Okay, the page is gone. The page crashed actually. Okay, the page crashed. Okay. So you have to be careful, because otherwise this simply runs while this is true, while the condition is true. So what can we do more? Let's do something more here. Let's do this while true. Okay. Well, this should run forever. It doesn't. Well, so what does it do? First, we have several interesting things here. This and this. What is this? This isn't modulo. This is actually a reminder. There's a difference between modulo and reminder. The difference is relevant for negative numbers, not positive. But what it for positive, what it returns, it's an operator. It returns the reminder of division. If I do something like 5, okay, I do this. Why? Because 5 divided by 3 is 1 and the remainder is 2. 7 divided 7 remainder 3. Well, it's 2 and the remainder is 1 because 2 times 3 is 6 plus 1 is 7. So it tries to divide it based on whole numbers and it gives you back the remainder. And that's actually returns -1. It should return 2. Modular arithmetics works differently than remainder arithmetics. That's only important for negative numbers. And positive modulo and remainder works the same. So what I'm asking, this returns number, and the number is converted to Boolean because it's an if statement. Modulo 2 or remainder 2 can only return two numbers, 0 and 1. There is no other remainder than 0 than 1. This is 1 remainder 1. I'm doing modulo 2. 5 is 2. 7. Let's do it this way. 7 is 3. A remainder is 1. 3 times 2 is 6. Plus 1 is 7. Well, that's the remainder for division. This is 4. Direct. This is 4. A remainder 1. This is 5. This is 5. A remainder 0. This is 5. Remainder 1. So this can only be 1 or 0. If it's 0, 0 evaluates to false. And 1 evaluates to true. So if this number is actually odd, because then the remainder is 1, let's do it. Let's log it out. And when the start is 6, because when the start is 6, then break. We've seen the break with the switch statement. What a break actually does, it terminates the statement that is above it, because you can nest statements inside it. So you can break from switch and you can break from loops. So how does it work? Okay, start is 1. 1 remainder 2, that's 0, and the remainder is 1, so this evaluates to true. Let's do 1. Okay, this is false, I don't care. Let's increment start, it's gonna be 2. 2 remainder 2 is 0, evaluates to false. I don't do this. We're talking about 2. I don't do this. 3. 3 remainder 2 is 1. Let's print out 3. This doesn't work. 4. 4 remainder 2 is 0. Ignore. We're talking about 4. Ignore. 5. remainder is 1. Let's print it out. Let's print out 5. 5, we don't care. 6. 6 remainder to 0, we don't care. 6 strictly equals 6, break from this cycle. So the break actually terminates the cycle. Sometimes you don't necessarily, the block in the condition may be complex, or in the cycle may be complex. So it may be easier to stick with the simpler condition and then break from it. Sometimes you do need, it may happen that you need actually while true. We're gonna run into it where we're gonna talk about generators, which is a complex issue. But you can always terminate using the break. Always. Okay, this will never come to here because the major condition here is start is lower than a 5. So when I'm 4, okay, I don't print 4, I don't care, this is 5, this evaluates to false. I no longer do the while cycle. I'm out of while cycle. It still does only up to 6. It doesn't print 6 because the remainder is 0. Breakout. So the breakout actually can break out from everything. Let's rewrite this. While does it run forever? Okay, I need this. I need this. Yeah, you do something wrong with the cycle and it's gonna run forever. Okay. Much better. Yep. Break. Okay, this is an interesting example. Why not? Okay, we have break here, but it doesn't work. Okay, now we have a new word here, continue. What does continue do? It goes back. So whatever is after the continue simply don't happen from the loop. It doesn't affect the if, but affects the while. So how does it work? So we're starting from 0, this start become 1, we have this here, this is unary operator. We usually understand operators working on 2 values. We've seen operator working on 3 values, the conditional operator. This works on a single value and it turns it to negative. So This becomes false. This becomes true. This becomes true. Why? Because it courses the string to Boolean, which is false, and negative of false is true. Where is it? The logical not turns the value into Boolean. All this is true, turned into Boolean. Negative is false. This is false. This is true for the very same reason. So, okay, 1. This is 1. Not 1 is false. So this doesn't happen. Prints out 1. And let's ignore this. 1, 2. This is 0. Not 0 is true. Continue. This doesn't happen at all. It continues with 2, 3. This is 1, not 1. It's false. Skip. Write 3. This doesn't happen. 4. This happens. None of this happens. This doesn't run at all. 4, 5. This doesn't happen. Let's write 5. This doesn't happen. 6. Okay, here's the 5, 6. Continue. 6 mod reminder 2 is 0, not 0 is true. Continue. So this doesn't happen. It continues. So this condition actually never happens. This is why it runs until we're 15, because now this is where it stops. But the continue actually terminates whatever is next, whatever is behind it in the code, and starts the loop all over again. That's why when I have it here, it ran forever, because it became, starts with 0, 0 reminder 2 is 0, reminder is 0, 0 divided by 2 is 0, reminder is 0, continue, and we're still at 0, because we never go here. So the continue terminates the run of the cycle and continues from the start. We would have to have this actually here for it to work. So in every cycle, every type of cycle, you can use either break or continue to start another iteration or break out of. But back to while, as I said, simplest possible example would be this. Okay, of course I have no increment here. I'm just outputting 0 over and over again. You know what, just end. So from 0, 0 becomes 1, 2, up to 14, this is still valid, this becomes 15, 15 is still smaller. So this is a condition, so this is a cycle, this is a loop with a condition at the beginning, which means this may never run. It doesn't run because this evaluates and this never runs. So this is a loop with the condition at the beginning. Let's check out do. Let me break it out so it never runs. Oh, okay. Let's do it this way, done one, done two, two. That looks like the same thing. We know about this. So this does the block. Again, there is a block here. While this is true. So again, it starts with 0, output 0, increments it. Is this true? Yes. 1, it becomes 2. Is this true? Yes. 3, 2 becomes 3. Is this true? Yes. 3 becomes 4. Is this true? Yes. 4 becomes 5. Is this true? No. So it outputs 1 to 4. This is a cycle, this is a loop with the evaluation at the end. What's the difference? Well, we already know this will never run. Because start is 0, 0 lower than 0, well, that's false, so this will never run. This will run at least once because the condition is at the end. So start is 0, let's output 0, start becomes 1, start 1 lower than 0, so it doesn't go back. So the loop with the condition at the beginning doesn't have to run. The loop with the condition at the end runs always at least once. I can do this here and it will still run because it goes from top to bottom and the condition is evaluated here. It works like this. 0, output 0, 0 becomes 1, 0 is lower than 2, let's go back. But the first time it has to go through the condition, through the loop. There are the same thing apply here. It goes to, let's say, 3, outputs 3, this becomes 4. This doesn't happen. While true, this is true, let's go back. Output 4, this 4 becomes 5, and there is a break. If this wasn't here, the cycle would run forever. So it doesn't output 2. Well, 0, 0 becomes 1. This doesn't happen, so let's output 1. That doesn't happen. Let's go here. 1 becomes 2. 2 goes directly here again. It simply breaks the loop. Not breaks the loop, it doesn't jump out of the loop, but it continues the loop again from the condition. It doesn't output the 2 here. This is a little bit tricky. This makes slightly more sense. Continue in this one. This jumps back and then jumps back again. It's weird, but it works the same. In both cases, there's a condition that has to be true for the block to happen. If the condition becomes false, the block exits. In both loops, you have a chance to break from the loop. I'm sorry. Break from the loop, or you have the chance to skip whatever happens in the loop after the call to continue and start the loop. Not start the loop all over again, but continue the loop from the beginning. In this case, from the end, because it still evaluates. Still evaluates. Let me put this to continue to here. So 0 here becomes 1. This doesn't happen. Let's output 1. This doesn't happen. 1 smaller than 2. 1 becomes 2. Continue. Jump directly here. Validates this. This becomes false. It ends. I hope it makes sense, sort of. The most important thing is there is a while loop or do while loop. One is with the condition at the beginning, one is at the condition at the end. And while the condition is true, the block works. The block is getting executed while the condition is true. There's a last type of loop, and it's a if loop, for loop, I'm sorry. It looks something like this. You don't even have to have this here, let's do it here. Okay, I'm declaring the variable. So I'm declaring the variable directly here. How does it work? There are 3 parts divided by semicolons. This part happens at the beginning. So at the beginning, this happens. Then this condition is evaluated. Is start smaller than 3. If this holds, it does the block. At the end of the block, when it's returning, this happens. And this is evaluated. So it's 0. 0 is smaller than 3. Do this. So let's output 0. Then this happens, start becomes 1, this evaluates. 1 is smaller than 3, let's output 1. And again, this happens. 1 becomes 2, this is evaluated, 2 is smaller than 3. Let's do the block. Then again, this happens. 2 becomes 3, 3 is not smaller than 3. Let's jump out. The important thing is to understand is that this simply runs at the end, which means while this looks like okay, it runs for 0, 1, 2 because of this condition, this will run always at the end. So although this cycle will run for 2 because this condition is valid, this will end. This will run, so the 2 will become 3, 2 plus 1 is 3. This fails, the block doesn't run, but this ran all the time. That's why this actually will be 3 after the cycle ends. So this condition is evaluated all the time, every time, even the first time. Nothing is happening. Start is initialized to 0, but start is not smaller than 0. 0 is not smaller than 0, so it ends. This doesn't even run. This runs after the block is running. So outside of the cycle, start is 0, and it didn't even run. 0 smaller than 1, so this runs, it outputs 0, and if a block runs, this runs. 0 becomes 1, 1 is not smaller than 1, and so the condition is valid all the time. This runs at the very beginning, and only at the very beginning, and this runs at the end of every block. You can turn for cycle, of course, into indefinite, for example, like this. I break out of it, so this condition is always true, so it runs forever, but I break out of it. Since I break out of it, it actually never went back, which means the start will stay 50, because this will never happen, because I break out of it. Other than that, it would run forever. You can turn it to run forever, for example, like this. It looks strange, but this will run forever. Because there is at the beginning, nothing happens. There is no condition. And in the end, nothing happens. So this runs forever. Yeah, this is gonna run forever. Okay, I run the same code again. Okay, very good. And it's truly this run, this run. There's another operator we haven't talked about, and it's operator comma. That's actually an operator. It simply does everything and returns the last thing. That's what it does. Comma sequence. Evaluates each of its operand and returns the value of the last operand. But it's an operator, which means okay, this works. This is one instruction. And by the way, you can declare two variables just putting comma between them this way. But it's a comma, so it doesn't create like another, it creates another expression, it creates another assignment, but it's still part of the first thing. So we declare a variable start, which is 0, variable stop, which is 5. Condition is start smaller than 5, stop is bigger than 3, and what should happen at the end is this. Again, one part, two expressions. So we increment start, we decrement stop. At the beginning, start is 0, stop is 5. Okay, though this is valid and this is valid. So let's write 0, 5. Then run this. 0 becomes 1, 5 becomes 4. Compare it. 1, 4. Okay, this is valid. Let's write 1, 4. At the end, this becomes 2, this becomes 3. Well, this is valid, and this is no longer valid. The condition fails, so the loop ends. We're done with 2 and 3. Because this ran, the condition failed, but this ran. So we have a matrix here. So first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, etc. Well, let's try to write it. Let's try to do it like this. Output it in our console. Well, how do we do it? Well, we have to manage somehow rows, and we have to manage somehow columns. Or you can do it like this. Doesn't matter. Perfect. Okay. What does it do? So we start with row 1, column 1, empty text. Okay, this is valid. So we have empty text plus you can add to text as well, the same way as you add numbers. So this is empty. So we add 1 times 1 and the space, and we say where with at the second column, and this is not gonna happen. So we continue. We add 1 times 2 and a space. Column is 3. This is not gonna happen. Okay, this is still valid. 1 times 3. Column becomes 4. If column is 4, we add the enter. We talked about the enter in the strings. We add an enter. We increase the row and we say, well, we add the first column again. The row is 2. 2 times 1. Column become 2. This is not gonna happen. 2 times 2, column becomes 3. This is not gonna happen. 2 times 3, columns becomes 4. We add another enter to the text. We're on a third row, and we're starting from the first column. We're on a third row, so this is still valid. 3 times 1, this becomes 2, doesn't care. 3 times 2, this becomes 3, doesn't care. 3 times 3, I'm sorry, this becomes 4. 4, add enter, a row becomes fourth row, column becomes first, but this fails. Does it make sense? Step by step? If I do it step by step, I can do it like this. Here you see the values at each step, and let's do it like this. Let's add text. Let's add the text to it as well. So at the beginning we have 1 1, we have 1 2, we're adding the text to it. We have 1 3, we added the text to it. We have and the enter. You don't see the enter here, you see the enter here when it actually enters as some sort of, when it's added, because it's added after we print it out. So we add enter, increase row, return column back to 1, and we construct this. This is a way how you can work with a loop to do it. While would be do while would be very similar. I'm gonna show it with for cycles. Okay, it works. This iteration is here at the end of the block, and I had to change this to 3, so it does that on 3, because the increment is at the end of the block. So again, we're starting from 1 1, and we're checking out the row lower than 4. It's lower than 4, it's smaller than 4. We again add the text. If the column is free, so we go from 1 2, this doesn't 1 1, this doesn't happen. 1 becomes 2, this applies. row is still 1. We go to 1, 2, then we go to 1, 3. At the end of the 2, we do this. This doesn't apply at the end of the 2, this becomes 3. So we create 1, 3. And if it's 3, we add the enter, we increment the row, and we start the column all over again. It doesn't matter. We can't tamper with the values within it. They're not constants. They're not fixed. So we restart column from 0, and we restart it from 0 because at the end this happens. So we're now at 2, 1. So we're at 2, 1. Now we're at 2, 2. Now we're at 2, 3. Because this changes 2 to 3. We're at 2, 3. 3. Insert enter. Now we're at third row. Column 0. At the end of the block, column 0 becomes column 1. This still applies because we're at row 3. 3, 1. Ignore. Becomes 2. 3, 2. Ignore. Becomes 3. 3, 3. Let's add enter. A row. Increment row to 4. Column 0. This fails. I hope it makes sense, but we can write it differently. This management is a little tricky to figure out what the condition, because here the condition in the while cycle, the condition was 4, and then the reset was to 1. It's a little bit tricky to figure out. So what we can do is actually this. Well, this looks like the best solution of all of them. It's very simple. So how it works, we start with the row 1. Okay, row is 1, row is, okay, that's valid. Let me do this again here without text, so the text doesn't bother us. We have the same steps. We can see 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3. No, it works. So we start with 1. This is valid. And we start another cycle here. Column starts from 1. This is valid, so this becomes 1, 1. Column increments, but this cycle continues, so it becomes 1, 2. Column increments, it becomes 1, 4. Column increments, it's 4. I'm sorry, 1, 3. Column increments, it becomes 4. So this cycle fails. We add the enter and the end of the string. Row is still 1, which means row becomes 2. This condition holds, and we'll start again the same cycle from column 1 to column 3. So we go 2, 1, 2, 2, 2, 3. This becomes 4. This fails. We add enter. A row is 2. We increment the row to 3. And we start the column again from 1. So we're at 3, 1. This happens. 3, 2, this happens, 3, 3, this happens, this fails, we add enter, and this happens, rows becomes 4, this fails. Does it make sense? I hope it does make sense. So it allows us to manage variables completely independently, because this counts row, this counts column, and we go each row, we go a column from 1 to 4, and then again from 1 to 4, from 1 to 3, 1 to 3, 1 to 3, 1 to 3, and for every row, from row 1 to row 3, we do something with the column, from column 1 to column 3. I can do like this. Let's make this. It's very simple. Still works. The matrix is perfect, fine. Managing matrix in the on this version of for cycle, or the while cycle, we would have to here, where does it change? No, they're independent. So we can nest for cycles, it doesn't matter. So those are the basic. By the way, break works perfectly, continue works perfectly. If column is 3, just break from this cycle, from the one cycle that's above me, which is this one. So I break from this when column is 3, I break out of it, so I continue with the next row. This changes nothing. Why would it? This skips 3 because there's a continue, which means, okay, this doesn't happen, I just go here, directly here. So the break and continue works as expected. Again, if I would do I would have only 2 rows. Because I skipped the enter here, so it continues here. I can do it like this, and I can skip the second row, because if the row is the second, just continue, turn the row into the third, and just skip everything else. So everything works as expected. So those are cycles. We have conditions that can branch out, and we have cycles that can make repetitive actions simpler to manage if they're continuously repetitive. If you have one after the same, after the same, after the same, that may change with the values of the variables, but it's always the same process, one after the other. Thanks for watching, and next time we're gonna talk about objects. Bronias out. See you next time.